Well, about quadratic equations, I'm going to be brief because we have a lot of material for these nodes, and the system is crashing and I'm having trouble uploading the videos. So I imagine that you have trouble also watching the videos. And it's going to get worse as more and more people connect and try to watch videos and download and so forth. So about quadratic equations, I just want to remind you that this is the main expression ax squared plus bx plus c equals 0. On the left we have a quadratic polynomial. We do not want a to be 0, otherwise the three coefficients are any real numbers, and we don't want a to be 0 because if a is 0, then the quadratic part disappears and it's not a quadratic equation anymore. Now, methods to solve quadratic equations, the most powerful one is the quadratic formula. That here it is. You have seen this before. The expression under the radical is called discriminant, and it's called discriminant because it discriminates. And here it is. Here is explained what it does. If d equals 0, you have only one real solution. If d is less than 0, you have two different complex solutions. If d is positive or greater than 0, you have two different real solutions. Now, the factoring method to solve quadratic equation is possible only if the discriminant is a perfect square, meaning 4, 9/16, 25, and so forth. Otherwise, if it is not a perfect square, you're not going to be able to factor it, unless you use special methods. Completing the square. Well, completing the square is equivalent to the quadratic formula, and we are going to review that either now or later. So here you have several problems, how to do it. Just go over that. If you have questions about any of them, please post the question to the open forum, because at this point I'm afraid that we are not going to be able even to do the online, the remote gathering. But let's see how it works. So there are many examples. I'm just going to skip some of them. By the way, here, notice that here it says this is probably from another book, so you don't look for these equations in our book. This is from another book. Whenever you see that you don't find the problem on the page, that means it's somewhere else. Okay, linear inequalities. Linear inequalities. Well, the main thing about linear inequalities is that instead of having equals, you're going to have some inequality symbol, whether it is less than or equal to, or greater than or equal to. And how do we solve linear inequalities? Well, let's see on page 132, number 8. We basically do the same as usual. So here we have it. Move 2x to the left, 6 to the right. Here it is indicated in red. Changing the sign. So 5x minus 2x is 3x. 1 minus 6 is negative 5. Then we divide by 3. And this is our answer. It says x is less than minus 5 over 3. On the number line, it looks like this. Since it is less, that means it's left from minus 5 over 3. And it's the whole interval. If you use interval notation, you say the whole interval from minus infinity to minus 5 over 3. Since x cannot be equal, because here it says less, since x cannot be equal to negative 5 over 3, we use parentheses. Remember, interval notation. So basically here we have three different ways of writing the solution for this inequality. First way is using this inequality form. Second way is using interval notation here. And last way is graphing the solution. Now, problem number 16. In problem number 16, we have what they say is a compound inequality. Look at the problem and notice that we have three parts to the inequality. We have this greater than or equal to 0 and 54 greater than or equal to this expression in the middle. So how do we solve this inequality, which is basically two inequalities in one? Well, we work on the three sides simultaneously. So we subtract 6 from all three sides, indicated in red. In the middle part, when we subtract 6, it just disappears. Otherwise, it's just as if you were moving 6 to the right with minus and 6 to the left with minus. Then you start simplifying and you get this. That is, x is a number is any number between -3 and 24, including -3 and 24. And because you have equality allowed, you use brackets for the solution when written using interval notation. And when you graph it, you do it like this. You don't leave an open hole, but it's a closed hole. And important when you solve inequalities, remember that every time that you divide or multiply by a negative number, you have to invert the inequality symbol, meaning here the inequality symbol is pointing to the right, and after you divide by -2, it is pointing to the left. That's what I mean when I say invert the symbol. That is a rule that you apply every time you divide or multiply by a negative number. And now, inequalities with absolute values. Well, here we are going to use two rules. Rule number 1, here it is. If the expression within absolute values is less than or equal to a number, then that expression it must be between -k and +k. So this will be a compound inequality. If the expression within absolute value is greater than or equal to a number, then according to this rule, you must solve two separate inequalities, this or that. So on page 132, you have problem 22 is 2x minus 9, absolute value of 2x minus 9 is less than 7. According to the first rule, you must solve a compound inequality, that is, put the expression between minus and plus the number. So I put the expression 2x minus 9 between -7 and +7, and I solve it by steps the usual way. Question 30.1 probably means it's not exactly 30, is this equation. Absolute value of x minus 7 is greater than or equal to 5. Greater than or equal, that means rule number 2. That means I have to solve two separate cases, and that is what I do. X minus 7 is less than or equal to -5, or x minus 7 is greater than or equal to 5. And I solve it by steps. When I finish, I end up with two partial solutions, and my final solution is the union of both partial solutions. Here is in equality form, both of them. Here is in interval notation. Problem 24 on page 132 and 26. Here you have it. In both cases, according to the rule, since it is absolute value greater than or equal to a number, I use the rule that requires separating and solving two different inequalities. I think is rule number 2. Let's see. Yes, rule number 2. So verify the steps. Everything is written in detail, and make sure you understand it. Pause the video and verify that you get exactly the same. So we continue. Problem 28. In problem 28, because you have absolute value less than or equal to a number, we must use rule number 1. And according to rule number 1, we solve this compound inequality. Now the interesting thing here is that we have negative 2x, so we have a negative coefficient next to x. That means once we eliminate 3, as we do in the second step, we have negative 2 here ready to be moved, or we are ready to divide by negative 2. And that means that we must flip the symbol. See already here, minus 5 minus 3 is negative 8, 5 minus 3 is 2, and next step, when we divide by negative 2, we flip less than or equal to 2, greater than or equal to, less than or equal to is flipped to greater than or equal to. And we end up having 4 greater than or equal to x, x greater than or equal to negative 1. That x is between negative 1 and 4, as shown here on the graph. And when we write using interval notation, we always keep in mind that the smaller number is on the left, less left, the greater on the right, as shown here also. Problem 32 is interesting because it tells you that the absolute value of 2x plus 7 is less than or equal to 0, but you know that it cannot be less than 0. So the only possibility is that it is 0. So you say, okay, if this absolute value is 0, that means the expression inside must be equal to 0. That means 2x equals negative 7 and x equals minus 7 over 2, or negative 3.5. Now the last topic in the notes is the topic of variation, and I am going to leave that for the next video.